said that this dripping faucet won't cause any major issue because the water's just going to go down the drain. No biggie, right? Away it goes. Okay? Okay, so let's do that. Let's go ahead and increase the flow rate. I don't know, let's increase it to 780 cups per hour.
That's a pretty random number.
Yeah, it is, isn't it? And go through the drain without it filling up. But let's say, okay, let's say instead of 780 cups per hour, we turn this up, or we have it up to 810 cups per hour. The capacity of this drain is 780 cups per hour. What's going to happen? That this sink is filling up. What is the rate at which this sink is filling up? 30 cups per hour. So what's going to happen? Let's say this holds, I don't know, 90 cups. What's going to happen?
Overfill.
3 hours later?
Yeah. So in 1 hour, it's going to be 30 cups full. In 2 hours, it's going to be 60 cups full. In 3 hours, it's going to be 90 cups full, which means that now, as it continues, we're ending up with a whole bunch of extra water going over the sides of our laundry sinks and getting all over the floor.
It's gonna flood.
Why would I be running that sink? Really good question. Really good question. I said at the beginning that this was a metaphor or an analogy, and I think because of the nature of our do now question, you have an idea of what it is. Okay, so what's this?
Square.
Bro.
That's
All right. So if we were to draw a circle representing our atmosphere that is 10 miles, here's Earth and its atmosphere. We have some numbers up there on the screen that were also in the activity you did yesterday, which are very similar to these, except instead of cups per hour,
miles per hour.
We have time to like do anything. Yeah, there's a metaphor for Earth that we know that. And the water is
none. What is the unit?
Gigaton.
Gigatons. Good. Gigatons.
Per hour.
Not per hour.
Per year.
Per year.
Let's get at it. That's
Per year that we're responsible for, on average.
30.
30. Okay. How many gigatons of carbon dioxide are part of the natural cycle?
810.
Yeah, 780 is natural cycle.
You lied to me. You little poo.
Year after year, we're taking carbon that isn't part of the natural cycle, and we're putting it into our atmosphere. The next year, it's 60. The next year, it's 90. The next year, it's 120. So, how long have we been putting carbon dioxide in excess of the natural cycle into the atmosphere?
9 years.
Probably like 300 years ago.
Over a century. Now, mind you, at the beginning of the Industrial Revolution, there weren't as many people burning as much oil, making as much stuff, driving as many cars, flying as many airplanes. There weren't any airplanes. But it's gotten higher and higher pretty much every year. And so we've accumulated a tremendous amount of carbon dioxide in excess of what the natural cycle. 30 gigatons.
Billions.
Why you say like that?
How many pounds? Ton equals 2,000 pounds. Therefore, when we have 30 gigatons, we have the 30 billion. That's 30 million, right? 30 billion tons times 2,000. So, 2 times 3 is 6. 60, 2 times 30, times 1,000, 1, 2, 3. And then we have our ring 0, 0, 0. That's 1,000, times another 1,000, times another 1,000. So, when we talk about 30 gigatons per year that are human caused, what we're really talking about is 60 trillion pounds per year. So all these numbers are dealing with CO2. 1 carbon, 2 oxygen, carbon dioxide, which is a gas. Carbon dioxide, di2, oxide, gas. Okay? We can multiply times the amount of cubic feet. Cubic feet, I'll just put FT for foot, a little cubed. 8.74 cubic feet per pound. So multiplying that. Okay. And when we do that, we get the number. I have to look at my little paper here. 524 trillion, 560 billion. So, hundreds and thousands, millions, billions, trillions. And that's cubic feet. Okay? Of CO2. Hard number to wrap your brain around. I don't know if I can wrap my brain around it, honestly. It's pretty big. Cubic foot, so it's about a foot, by a foot, by a foot. 524 trillion, 560 billion of those per year from human-used fossil fuels. All right, so one last step. This is still a really hard number to get your brain around. So I looked up something you might have a better chance of visualizing, which is an Olympic-sized swimming pool, one of those like the largest pools you see. The one over at USF, if you've ever been in that place, is Olympic-sized. It's 88,263 cubic feet. So if we divide into this, divide out the cubic feet, and get the amount of or rather number of Olympic-sized swimming pools, we end up with 5,943,150,000 Olympic-sized swimming pools. So that's the volume, that's the amount of carbon dioxide that we put up into the atmosphere in excess every year, more or less. It's a lot of excess carbon dioxide from burning fossil fuels.